So how can you do this problem in 30 seconds or less? A machine part is supposed to be 0.38 millimeters thick. The manufacturer allows a variation of -2.5 to +2.5%, which interval shows the range of acceptable thickness in millimeters for the part. So I'm going to go with 0.38 divided by 40, I get roughly 0.01. So I'm in between 0.37 and 0.39. It's between G and H, but G is so much closer. That's the answer. How was I able to do this problem so fast? We need to essentially calculate what is 2.5% of 0.38, which makes it very complicated for the computation without the calculator. So you have 0.38 and you need to multiply this by 2.5%. So it's going to be 0.38 multiplied by 0.025. You're going to spend forever trying to make this computation. We do know that 2.5% is equal to 100 divided by 40, all right? Because 40 multiplied by 2.5 is equal to 100%. That we know. How do we know that? Well, we also know that 4, for example, multiplied by 25 is equal to 100%. So if you take the decimal here and then add the 0 here, 40 times 2.5, that's also going to be equal to 100%. What does it mean? It means that 2.5% is equal to whatever, in our case, 0.38 divided by 40 from here, right? So we just divided by 40. Now, a super dirty, quick and dirty approximation is you just get 0.01 roughly. Why? Well, because 0.38 is roughly 0.40 divided by 40, so obviously it's just 0.01. Now, you have 0.38 as your average, so it's 0.38, and then you add and subtract 0.01, so you get somewhere between 0.38 minus 0.01, that's your low barrier, and then upper barrier 0.38 plus 0.01. So this one is 0.39, this one is 0.37. So that is your rough range. Now clearly E is out and F is out because these ranges make no sense. It's between G and H, because 0.37 or 5.3895 close to 0.39, and same here, right? So how to select it? A quick and dirty approximation again, I'll just go with G, because 0.37 is so much closer to 0.3705. But what if my approximation didn't work? What if I failed with my approximation? Thus, it's really H, but I selected G. What can I do? Well, in this case, we can actually go ahead and do a full computation. So if we have, like, I would still not do 0.38 times 2.5%. That will still take me forever. But I will do 0.38 divided by 40, and I'll just do a more accurate approximation. So what is that equal to? This is equal to 0.4 or 0.40 minus 0.02 over 40. Now this is 0.01. This is minus, so it's 0.02 over 40. So if I multiply by 25 and I also multiply this one by 25, I get 0.50 over 1,000, which is equal to 0.0005. So I get 0.01 minus 0.0005, which is equal to 0.0100 minus 0.0005. So it's essentially 100 minus 5. So it's 0.0095. So again, if you don't have time on the test, don't do this. Just do quick and dirty approximation. If you want to be 100% sure, you have to do something like that. So that's 0.0095. So we get the mean of the average of 0.38 plus or minus 0.0095. You see how this is super close to 0.01, right? So therefore, of course, like we can already see that it's G, but just for the sake of it, so 0.38 plus for the upper boundary plus 0.0095, we're gonna get 0.3895. It's magically matching this upper boundary, so it's clearly not H, because H is 3876. So H is out, G is the answer. That's it.